When voltage is applied to a coil, a current will flow. In this example, current flows into the right-hand side conductor of the coil and out the left side conductor of the coil. Due to the interaction between the rotating field of the armature coil and the motor's main field, a downward force is applied to the right side of the coil and an upward force is applied to the left side of the coil. This results in a rotational force or a torque that is applied to the coil. Commutation is the act of reversing the current in the armature at the correct time. It's necessary to continue having rotational force on the armature coil as it rotates in the magnetic flux provided by the main field. As the conductor passes through the North Pole field, enters the South Pole field, the current in the coil must be reversed in order to maintain the rotation. As the rotor rotates, so does the commutator, switching the coil side connection from one polarity brush to the other polarity brush. This reverses the current flow in the armature coil. And this reversal of current direction ensures a continuous rotational force on the armature, allowing the motor to rotate. Once the current is reversed in the armature, the rotation force is continued. What happens when a single coil is centered between field poles? That's when there's no interaction between fields and therefore no rotating force. The coil can actually get stuck. The answer is to add another coil so that a force is always in play to maintain the rotation of the armature. Adding another armature coil and commutator bar segments ensures the continuous rotation. As the coil rotates, the current is reversed at the position that is centered between field poles. This precise position is called the neutral axis. Flux refers to the magnetic field produced by the electromagnets within the motor. This shows the flux flowing from the North Pole to the South Pole and then through the iron in the frame. The amount of flux is determined by the number of turns in the field poles and the amount of current that flows in the field pole coils. Flux is amp turns. The flux curve refers to the relationship between the magnetic flux produced by the field winding and the amp turns. When the current is low, the flux increases linearly with the current. However, as the current increases, the curve starts to flatten, eventually reaching a point of saturation where further increases in current have little effect on the magnetic flux. Torque is a measurement of the rotating force generated by the motor, which is responsible for its rotational motion. A simplified torque equation in a DC motor is given by the product of the motor's armature current and the magnetic field strength. Simply put, torque equals the armature current multiplied by the magnetic field strength multiplied by the armature conductor length.